Okay, what I'm going to do is I'm going to go over one of the homework problems. I picked one out, it was a tougher one, which is number 5. And I'm going to show you, this is one way to solve this problem, and I want to be clear about this. There are multiple ways to solve this problem. That's the thing about physics. But I'm going to show you one way, and then I'm going to make another video to show you how to solve it another way, okay? All right, so a ball I guess, thrown up at 30 meters per second from the top of a cliff of height 50 meters. About how long would it take for the ball to hit the ground? And what was the ball's velocity? So I'm going to attack that first problem first. So there's a picture. I'm just going to redraw it a little bit so that I have a visual. So this ball is being thrown up with a velocity, an initial velocity of 30 meters per second. Now, since I'm calling that positive 30, I'm just going to go ahead and, you have to set up a coordinate system. You have to kind of let people know what you're going to be calling positive. So I'm going to just go ahead and say that this is going to be right here, is going to be my initial position. Now, normally, since it's moving up and down, we'd call that y0, right? But since I already know that I'm going to be looking at my equation sheet, which has everything written in terms of x, I'm just going to go ahead and call that my initial position in the x. And I hope you're okay with that. So I'm going to call up positive. Right here's where I'm going to call 0. And we know that this thing's going to go up, 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 and then down here. And we say that this part is where we're going to call our final position here. We know that this is at 50 meters above ground because that's what the problem says. Okay, so this is going to be where we're going to call our final position. Okay. Okay. Oh, since this is positive 0, positive is up, I'm going to call that negative 50 because it's going to be 50 meters below our initial position. So to be proper here, that's why it's important to let everybody know that's positive, up is positive, and this thing's going to be 50 meters below our initial position. Okay, then I encourage you to say given. What do I know? I know that the initial velocity is 30 meters per second, positive. Since I know gravity is in effect here, I also know that the acceleration is equal to, now we know gravity is going to be accelerating this thing down 10 meters per second per second. So I'm going to say negative 10 meters per second per second. So it's going to be accelerating down. I don't know my final velocity, but I do know my final position is negative 50 meters. And that's about all I know. Unknown. What am I looking for? I'm looking for how long. So that time is what I'm looking for. At that point, I'm going to move this, and I'm going to look at my equation sheet. And I have to find something that relates my initial velocity, my acceleration, my final position, my time. You'll notice that the first equation doesn't really work. The second equation has everything I need. So does the second one, but this one doesn't have time. The third one, this one doesn't have time, so it's not really going to help me. So the one that I really need to use is that one. Okay, so I'm going to go ahead and write my equation, which is going to be copy right off there. X is equal to our initial position plus our initial velocity times time plus 1/2 acceleration times time squared. Okay, all right, I'm going to remove all that. Now, substitute and solve. Now, you'll notice that I'm not doing this in the worksheet because I'm going to need the space. So if you want to do this on a separate sheet of paper, that's great. So I'm just going to rewrite my equation just one more time so that it's easy for me to follow along, and hopefully you too. And one by one, I'm going to start substituting stuff in. I know my final position is negative 50 equals my initial position. I went ahead and called it 0 plus my initial velocity, which is positive 30. Now you'll notice I'm leaving out the units so I don't get lost, and that's okay. Plus 1/2, a t squared. My acceleration is negative 10 times time squared. All right, there you go. Let's massage this a little bit down so that it's a little bit easier to follow. Negative 50 is equal to 0. I don't have to write that. 30t plus 1/2 from -10 is -5. So I should probably -5 right there. At this point, you're probably saying, what do you do? Now you can clean this up a bit. You'll notice that this is a quadratic. And so off the bat, you might think maybe I should factor or something like that. And it might not look like that. So we're going to change this a little bit here. I'm going to move this term in the front. So it's a -5t squared plus 30t equals -50. All right. And it's starting to look a little bit more like something you can use. So the next thing I'm going to do is I'm going to add 50 on both sides. So what I do on one side, I got to do to the other. This goes by and becomes 0. So what we end up with is -5t squared plus 30t plus 50 is equal to 0. Now we're there. Now we're looking like something that we can solve. There's a few things that you can do in order to make this a little bit easier. Off the bat, I noticed that that's a -5. It's going to make things a little bit complicated. So one thing you can do is you can divide everything by -5. And you'll see why I want to do that in a second. What you do to one side of the equal sign, you got to do to the other. 0 divided by -5 is going to be 0. This becomes positive t squared. Positive 30 divided by -5 is -6t. And this becomes -10 is equal to 0. Now we're here. At this point, what you want to do is you could try and factor this out. And you'll notice it's not a nice factoring. So I want to remind you of something that you got to use. You got to use our friend, the quadratic formula. The quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, where this would be, the 1 in front of this would be a, this would be b, and this would be c. And so you plug those numbers in here to find whatever t is going to be. So t is equal to -b, which is -6, plus or minus the square root of b squared, which is -6 squared, minus 4a, which is 1, c, which is -10, all over 2a. A is a convenient one. And that's why I wanted to divide that negative out, because it might get a little bit messy. Then you kind of simplify this a little bit more. Negative of negative is positive, so 6 plus or minus the square root. -6 times -6 is positive 36. This negative times negative is plus 40 all over 2. Once again, we can simplify that a little bit more. T is equal to 6 plus or minus the square root of 76 over 2. And at this point, we have two solutions, right? So we're just going to go ahead and do this. And I kind of did this. You can find the square root of 76, and you'll find that that would be 8.72. So T is equal to 6 plus or minus 8.72 over 2. So 6 plus that would be 14.72 divided by 2, and you get two solutions. So 6 plus, so T would be either equal 7.36. Well, you might want to convince yourself of that. So let me do that for you. All right. 6 plus, really see that. 6 plus 8.72, 6 plus 8.72 divided by 2 give us 7.36, that's 1. And then you'll notice that if you do 6 minus 8.72, you're going to get a negative number. So the other one's going to be, negative 2.72 divided by 2, and it gives you like negative 1 point something. So here, get that out of the way. Focus that. So when you put, once again, 6 plus 8.72 gives you 14 point something, 4.72, and you divide it by 2, you get 7.36. When you say 6 minus 8.72, you get negative 2.72 divided by 2, and you get negative 1.36 or something like that. So that would say t is equal to negative 1.36. So you have two solutions. Which one would it be? Well, negative time doesn't make any sense. So that means our final answer would be positive 7.36. And that's how you, okay? That's one way, and I'll make another video to show you how to solve that a different way, okay?